Hello everybody. This is exactly where we left off on our last video, writing formulas and names. We just introduced polyatomic compounds, so make sure you have maybe a list in front of you or next to you handy to refer to until you get those memorized. You do need to get those all memorized very, very soon. This week, as a matter of fact, because we will have actually a little quiz covering those in, again, naming the compounds and writing formulas. Okay, so let's go ahead and start here. Again, this is right where we left off before. We have sodium, and this is acetate. So take a look at your chart and make sure, again, just a reminder that you have your periodic chart out in front of you. What is the oxidation state of sodium? It should be 1. And the oxidation state of acetate is also 1. And so no different than what we've been doing before with the ionic compounds. Now remember that these polyatomic compounds, when they form with these other elements, they are still considered, when they form with a metal, are still considered an ionic compound. So these oxidation states are switching. We are losing and gaining electrons here. Okay, so in that case, let's go ahead and give the formula first. We have sodium, and then this is acetate, C2H3O2. You can put parentheses around there. I kind of suggest that you do. Again, it alleviates mistakes in that area as well, and it just isolates that polyatomic for you. You don't have to put parentheses around there unless there is, let's say there was a subscript out here like this. In that case, you definitely would have to put the parentheses around that polyatomic. Remember, a polyatomic is more than one atom, and they behave actually as one. So we are never going to take this apart or alter these subscripts or anything on this polyatomic. It is what it is, okay? So we switched those oxidation states of sodium and acetate. They were both 1. So again, we don't write the ones. So this is what you should have for the formula. And then to say the name, you would simply have sodium and then acetate. We do not alter the names in the polyatomics either. So acetate is acetate, hydroxide is hydroxide, nitrate is nitrate, and so forth. We're never going to change those names or add IDE to any of these polyatomics like we did before when we had a metal and a nonmetal. So the polyatomics actually do stay as they are currently named. Let's take a peek at the next one. We have potassium with hydroxide. Potassium has an oxidation state of 1. Hydroxide has an oxidation state of 1. If we switch those oxidation states, it is simply written like this. Again, you can put the parentheses around there just to remind you that it is a polyatomic. And then we name it potassium hydroxide. Again, do not change that name on that polyatomic. Okay, let's try the next one. We have zinc with nitrate. Zinc has an oxidation state of 2. Excuse me, my pen just stopped again. Nitrate has an oxidation state of 1. Switching those oxidation states, the 1 is going to come after the zinc. The 2 now is going to come after the nitrate. And it will look like this. This is what I was talking about as far as needing the parentheses, most definitely here, because you have the subscript outside here, right here. So this is actually telling me I have 6 oxygen, 2 times 3, and 2 nitrogen, still only having 1 zinc. So again, the subscript on the outside of the parentheses multiplies times everything inside these parentheses, now giving us 6 oxygen and 2 nitrogen. Now to say this, again, do not alter that polyatomic name. You probably already have it written down, I hope. Zinc nitrate. Very good. Next one, aluminum. Aluminum has an oxidation state of 3. Sulfate has an oxidation state of 2. Keep that list handy until you get to memorizing all of these polyatomics. Switching those oxidation states, the 2 is now going to come after the aluminum. The 3 is now going to come after the sulfate. Al2, SO4, 3. Now here, just to go over that again, we have 12. 3 times 4 is 12 oxygen. 3 times 1 is 3 sulfur, and 2 aluminum. So this 3 only applies to what is in these parentheses right there. The name, aluminum sulfate. Nice. Last one, calcium. Calcium has an oxidation state of 2. Phosphate has an oxidation state of 3. Again, the 2 is going to go here, the 3 is going to go here. We are switching those oxidation states. Ca3, PO4, 2. We now have 8 oxygen, 2 phosphorus, and 3 calcium. The name, calcium phosphate. Easy enough. Now, let me give you some names, and you have to give me the formula. Get them all pulled up. Get my pen going. Okay, calcium carbonate. We know that the oxidation state of calcium is 1. The oxidation state of carbonate is 1. I still like putting the little numbers up there. Again, I think it's very helpful and alleviates making mistakes. So let's continue forward. Calcium carbonate. Calcium carbonate, CaCO3. Both having an oxidation state of 1. I don't have to switch it. Remember, you do have to switch it in the formula. Next one, ammonium sulfide. I know ammonium has an oxidation state of 1, and sulfur has an oxidation state of 2. So be careful. Make sure you switch those oxidation states in the formula. So I know ammonium is NH4 and sulfur. Remember, the 2 has to go after the ammonium, the 1 after the sulfur. And that's where that comes from. We switched those oxidation states. Let's try another. Sodium hydroxide. Sodium has an oxidation state of 1. Hydroxide an oxidation state of 1. Easy enough. NaOH. And again, if you want to put those parentheses there, feel free to do so. Next one, manganese Roman numeral 4 sulfate. So remember that Roman numeral is telling me the oxidation state of manganese is 4. And if I look at sulfate on our polyatomic sheet, that has an oxidation state of 2. So be very careful writing this. We have manganese. I'm just going to kind of separate them out here just for kicks. And we have sulfate. Remember, the oxidation state of manganese was 4, so it's going to come over here. And the oxidation state of sulfate goes over here now, which was 2, because they switch. I hope that's really clear. On the next one, we have iron Roman numeral 3 sulfate, telling us that iron has an oxidation state of 3 because of the Roman numeral. Sulfate, if we look at our polyatomic sheet, sulfate does have an oxidation state of 2. Remember, the 3 is now going to come after sulfate, and the 2 is going to come after iron. So when we write that, it should be Fe2, SO4, 3. Remember, that belonged to the iron, and this belonged to sulfate. Ammonium phosphate. Ammonium has an oxidation state of 1, and phosphate has an oxidation state of 3. So let's give this one a try. Ammonium first, NH4. I'm just going to go ahead and write them just like this, just for kicks again, and we have phosphate. Remember, phosphate had an oxidation state of 3, so it comes over here, and ammonium had an oxidation state of 1 here, but again, we don't write the 1s. So we have NH4, 3, PO4. You have to have these parentheses here when you have a subscript outside of these parentheses. So this is telling me 12 hydrogen, 3 nitrogen. Over here I have 4 oxygen, 1 phosphorus. Okay? Now that we've introduced polyatomic compounds, right in their names and their formulas, I want to move forward and start with covalent compounds. A covalent compound, don't forget, 2 nonmetals. You always write the element closest to the metals first. You have to use a prefix when naming these compounds. So these are the prefixes you must memorize. I will not be giving these to you. So you have to get used to using these, knowing them, love them, wrap your arms around them, make flashcards, just really, really make sure you know these, okay? Let's take a look here. I have a couple listed here in the yellow. Make sure my pen is working. N2O. You can see that that is 2 nonmetals. So with the beautiful thing about covalent compounds, you just write what you see. Literally write what you see. So this is telling me there's 2 nitrogen, 1 oxygen. We will use mono with oxygen only. So here I'm going to say dinitrogen monoxide. I wrote exactly what I see. Nothing tricky, no switching, nothing. It's actually, they're very easy. Easier than ionic compounds, I think. Let's try another one. We have NO. We have 1 nitrogen, 1 oxygen. Let's go with nitrogen monoxide. Again, we're only going to use mono with oxygen. If the others have just 1, we'll leave it as is. Nitrogen, there was only 1, we'll leave it at nitrogen. Let's try another. Here there's 2 oxygen, so I know I have to use the prefix di because all of these are covalent compounds, 2 nonmetals. So this one would be nitrogen, now we say dioxide, still ending in IDE. The next one, this is a fun one. Here we have 2 nitrogen, 5 oxygen. Simply go to the prefixes. 2, we'll use di. 5, we'll use penta. So just simply write what you see. I have to tell you I have dinitrogen and now pentaoxide. Good, very good. Let's write just a couple more on the next slide. I have like 2 more minutes left. Carbon plus oxygen. We know, let me put them all up here. Whoops. The oxidation state of carbon is 4. The oxidation state of oxygen is 2. That would give me the switch. Give me C2O4. Writing it in the simplest form would give me CO2. This is a covalent compound. Write what you see. I have 2 oxygen, carbon dioxide. Sulfur plus chlorine. Sulfur has an oxidation state of 2. Chlorine 1, they switch, so I will have FCl2. I would write that. Sulfur, dichloride. 2 chlorine, 1 sulfur. Very easy. Carbon plus hydrogen. Carbon has an oxidation state of 4, hydrogen 1, CH4, take a peek at your prefixes. Carbon, hydrogen. You write what you see. Very simple. Now for me to give you the name, if I To reverse this and say carbon tetrahydrogen, again, you write what I tell you. Covalent compounds, very straightforward. Talk to you tomorrow more about these covalent compounds.